scientists might have found proof of alien life, but misunderstood it. According to a professor at Harvard University, strange radio waves that have been reaching Earth might actually be leakage from a huge, light-powered ship deep in space. Fast radio bursts FRB, which have perplexed scientists since they were discovered in 2007, could be evidence of advanced alien technology, according to A.V. Loeb of the Harvard-Smithsonian Center for Astrophysics. Researchers, however, remain far from establishing whether the source of these messages is what Loeb speculates it is leakage from planet-sized transmitters that are powering interstellar probes in distant galaxies. Fast radio bursts are exceedingly bright given their short duration and origin at great distances, and we haven't identified a possible natural source with any confidence, Loeb has said. An artificial origin is worth contemplating and checking. Fast radio bursts are flashes of radio emissions lasting milliseconds, whose source is yet to be identified. They were first picked up in 2007 when scientists came across data that showed a burst had occurred in 2001. While few have happened since that time, scientists have discerned that FRB arrive in apparently organized patterns. Loeb and fellow Harvard academic Manas Velingham have explored whether the messages could emanate from a radio transmitter in a paper to be published by the astrophysical journal Letters. This would require a planet-sized solar power generator to pelt messages across the galaxy. Such technology is far beyond human capability now, the Harvard scientists note, but it is not beyond the laws of physics or out of the reach of a very developed alien civilization. Loeb and Velingham found such a technology would require so much energy it would just end up melting itself unless it were water-cooled and twice the size of the Earth. What is less clear is why an alien civilization would build such a thing in the first place. But the researchers speculate that the energy being sent out is driving interstellar light sails, where spacecraft ride along on light waves, in the same way a boat moves through the ocean. Whatever is generating the FRBs is powerful enough to push around something weighing 1 million tons, or about 20 times the biggest cruise ships ever built. That's big enough to carry living passengers across interstellar or even intergalactic distances, said Lingham. To power such a craft, the transmitter would have to be constantly pointing its beam towards wherever the ship was in space. If that were happening, we would only pick up brief flashes of energy, because the ship itself, the planet powering it, and its own star and galaxy would all be constantly moving too. That would explain why the burst comes to Earth repeatedly but intermittently. Scientists haven't been able to explain FRB patterns with reference to the huge astrophysical events required to dispatch huge amounts of energy towards us. It would also explain the frequency that the radio waves are pitched at. The optimal frequency for powering such a light sail is similar to the FRBs that have been detected, according to the professors. Loeb says that his work is speculative and that more work must be done to check whether such an idea would be possible. It doesn't matter whether or not he believes that they are caused by aliens, he said. Science isn't a matter of belief, it's a matter of evidence. Deciding what's likely ahead of time limits the possibilities. It's worth putting ideas out there and letting the data be the judge. The paper, Fast Radio Bursts from Extragalactic Light Sails, is already available online. It speculates on the mass of the hypothetical light sail and the angular velocity that any beam would be sent at. There is a limit to how well we can measure time. With quantum mechanics and general relativity resulting in a blood flow, scientists have discovered, in a study published in the journal PNAS, a team from the University of Vienna and the Institute of Quantum Optics and Quantum Information were looking at what happens to time when you factor a clock into the mix. Normally, you would not think clocks affect space or time, and that time can be measured accurately at different points in space. But this is not the case if you are a theoretical physicist. Quantum mechanics says that there is a fundamental limit to how precise we can measure physical properties of a pair, like the time of a clock and energy. This sort of works on an inversely proportional scale, so the more precise the clock, the more uncertain its energy becomes. This means the most precise clock would have limitless uncertainty relating to its energy. The next thing to consider is Einstein's theory of general relativity, which says the flow of time is altered by masses or sources of energy. As a result, time runs slower near an object of large energy and faster when it is near an object with a smaller energy. So what happens when you combine these principles? Researchers found that when you place clocks next to each other, they would disturb each other. This led to a flow of time, meaning there is a fundamental limit to our measurements of it. The more precise a clock, the more it flows the flow of time of the other clocks near it. Based only on the assumption that both principles hold in this situation, we show that the clocks necessarily get entangled through time dilation effect, which eventually leads to a loss of coherence of a single clock. Hence, the time as measured by a single clock is not well defined, they wrote. A huge ring of galaxies spanning 10 billion light-years is challenging Albert Einstein's theory of gravity. The cluster appears to be moving away from us far faster than it should be, expanding like a mini Big Bang, and this means our current understanding of gravity is not quite right. In two papers, one published in the monthly notices of the Royal Astronomical Society, and the other currently under review, scientists observed the speeds at which a group of galaxies in our local universe are moving. At present, the Milky Way and our closest neighbor Andromeda are moving towards each other at a speed of around 110 kilometers per second. In the past, however, the two galaxies flew past each other, creating a slingshot effect on lots of smaller galaxies, sending them flying out into space. Lead author Indra Nilbanik said, the ring-like distribution of the group of galaxies is also very odd. I found there's barely a 1 in 640 chance for randomly distributed galaxies to line up in the observed way, he said. I traced their origin to a dynamical event when the universe was only half its present age. In Einstein's gravity paradigm, hypothetical dark matter is always invoked. Such a high speed requires 60 times the mass we see in the stars of the Milky Way and Andromeda. However, the friction between their huge halos of dark matter would result in them merging rather than flying 2.5 million light-years apart, as they must have done. The researchers say that, if correct, the speed of the galaxies could only be explained if gravity gets weaker as galaxies drift apart, as the standard model currently suggests. Several aspects of the spatial distribution of these galaxies would be expected to occur if there was a past close MWUN-31 flyby, they wrote. Such an event only makes sense in the context of certain modified gravity theories, where galaxies lack massive dark matter halos and their associated dynamical friction in close encounters, which would otherwise cause a merger. Marcel Pawlowski, a Hubble Fellow at the University of California, Irvine, commented, science progresses through challenges. Together with two other known planes of closer-in satellites, this gigantic ring forms a serious challenge to the standard paradigm.